I'm a bit nervous, to say the least. Right, okay. This might seem a bit... Well, actually it is. I don't know how to even explain it. Making a lateral move. Like trying to understand Wayland client, at least for me, seems to be as hard as writing one. So I think I've decided to write Wayland client. Because why not? Well, I mean, plus I got inspired by a YouTube video. I'll share it in the description later. Okay. But I found a few resources that would think be helpful in achieving this. I did come across this blog when I was looking at Wayland client. Right, okay. So I'm gonna read it a little bit and then, yeah, I guess write a client from scratch. High level design. Mobile device. Okay, I don't know where to start. I guess from the beginning. A computer has input and output devices which respectively are responsible for receiving information from you and displaying information to you. These input devices take the form of keyboard, mice, touchpad, touchscreens, drawing tablets. Your output devices generally take the form of displays on your desk or your laptop or mobile device. These resources are shared between all of your applications, and the role of the Wayland compositor is to dispatch input events to the appropriate Wayland client and to display their windows in their appropriate place on your outputs. The process of bringing together all of your application windows for display on an output is called compositing. The process of bringing together all of your application windows, okay? Excuse me. And this we call the software which does this, the compositor. Right, okay. In practice, there are tools like Mesa for rendering, the Linux KMS DRM system, buffer allocation with GBM, the user space lib library, lib input, and evdev. Oh, I think this is the input client. Or so I read this somewhere before. Not sure exactly what it does. Understanding expertise with most of the system is not required for understanding Wayland, and in any case are largely beyond the scope of this book. Wayland protocol is quite conservative and abstract, and a Wayland-based desktop could easily be built and run most applications without implicating any of this software. Okay. That being said, a service level understanding of what these pieces are and how they work is useful. Let's start from the bottom and work our way up. Perfect. Yeah, then some understanding is important because it helps later when I get stuck. If I get stuck. A typical computer is equipped with a few important pieces of hardware. Outside the box, we have your displays, keyboard, speakers, some USB, cup warmer. It's not a bad idea. There are several components inside the box for interfacing with these devices. Your displays are plugged into GPU. Oh, sorry. Your keyboard and mouse, for example, are probably plugged into USB ports, for which your system has a dedicated USB controller. These systems have their own objects and state. For example, your GPU has state in the form of memory for storing pixel buffers in, and jobs like scanning out these buffers to your displays. Your GPU also provides processor, which is specially tuned to be good at highly parallel jobs. Okay. Such as calculating the right color for each of the 2 million pixels on a 1080p display. Bad at everything else. The USB controller has the unenviable job of implementing the legendarily dry USB specification for receiving input events from your keyboard or instructing your coaster to assume a temperature carefully, blah blah blah. At this level, the hardware has little concept of what applications are running on your system. Hardware provides an interface which can be commanded to perform work, and this is what it's told. For this reason, only one component is allowed to talk to it, the kernel. The kernel is a complex beast, so we'll focus on only the parts which are relevant to Wayland. Linux's job is to provide an abstraction over your hardware so that it can be safely accessed by user space, where our Wayland compositors run. For graphics, this is called the DRM, or Direct Rendering Manager, which efficiently tasks the GPU with work from user space. An important subsystem of DRM is KMS, kernel mode setting, for enumerating your displays and setting properties such as their selected resolution. Input devices are abstracted through an interface called EVDEV. Kernel interfaces are made available to user space by special files in /dev. In the case of DRM, the files are in /dev/dri. Why not DRM? Usually in the form of primary node. Cut 0 for privileged operations like mode setting, and the render node, render D128, for unprivileged operations like rendering or video decoding. For EVDEV, the device nodes are /dev input /event star. Interesting. /dev. Oh yeah. Interesting. Is there a card? Oh, there is a card. Not sure what that card is. That's interesting. Now we enter user space. Your applications are isolated from the hardware and must work. I should probably zoom this in a bit. It must work via, excuse me, the device nodes provided by the kernel. I wonder if I can skip some of these. XKB common. libwayland is the most commonly used implementation of the Wayland protocol. It is written in C and handles much of the low-level wire protocol. It also provides a tool which generates high-level code from Wayland protocol definitions. Detail in chapter 1.3. Okay. Golden target audience. What's in the package? Where do you find this XML? Okay. So this is the chapter that I'm most interested in. I guess then I could get started. We're just going to use libwayland now. Okay, so I don't need to skip it. The wire protocol is a stream of 32-bit values coded with host byte order. Example, little endian on x86 family CPUs. These values represent the following primitive types. Int uint, 32-bit signed and unsigned integer fixed. 24 8-bit signed fixed point numbers. 24 8-bit signed fixed point numbers. Object is a 32-bit object ID. New ID is a 32-bit object ID which allocates that object when received. Okay. In addition to these primitives, the following other types are used. String. Prefix with a 32-bit integer specifying its length in bytes, followed by the string contents and a null terminator. Added to 32 bits with undefined data. What does that mean? Added to 32 bits with undefined data. I am not sure what that means. I can check that later. Encoding is not specified, but in practice, UTF-8 is used. Array. Blob of arbitrary data prefixed with a 32-bit integer specifying its length in bytes, then the verbatim contents of the array added to 32 bits with undefined data. Prefix with 32-bit integers similar to a string. What's this padding? You mean like, is it like towards the end? FT. 0-bit value of the primary transport. Transfers a file descriptor to the other end using the ancillary data in the unit domain socket message. Enum, a single value from an enumeration of known constants, coded into 32-bit integer. Okay. Seems not bad. So basically, to read the string, you get the length. How do you know? Oh, okay, because it's defined, I guess. Okay, so this is the order, which I guess. Okay. Messages. The wire protocol is a stream of messages built with these primitives. Wire protocol is a stream of messages built with these primitives. I thought this was quite cool. I did have a sneak peek. Every message is an event. In the case of server to client messages or request which acts upon an object. Acts upon an object. The message header is 2 words. The first word is the affected object ID. The second is 2 16-bit values. The upper 16 bits are the size of the message, and the lower 16 bits are the event or requested opcode. So I wonder, can it just be the message header is 2 words. I think a word is 32-bit. Right, well, that would be my guess, because the second word is 2 16-bit values. The first word is affected object ID. The second is 2 16-bit values. The upper 16 bits are the size of the message, including the header itself. Okay. And the lower 16 bits are the event or request opcode. Okay. The message arguments follow based on a message signature. The message arguments follow based on a message signature agreed upon in advance by both parties. The recipient looks up the object ID's interface. Object ID's interface. Somebody cutting grass at this hour. Maybe. So my guess is you pass these in the message and it'll be called as such by the interface. Recipient looks up the object ID's interface, and I think object ID, is there a list of IDs? And the event or request defined by its opcode to determine the signature and the nature of the message. To understand the message, the client and server have to establish the objects in the first place. Object ID 1 is pre-allocated to the Wayland display singleton. Okay. It can be used to bootstrap other objects. Object ID is pre-allocated as the Wayland display singleton and can be used to bootstrap other objects. We'll discuss this in chapter 4. The next chapter goes over what an interface is. Okay, that's good. And how requests and events work. Assume you've already negotiated an object ID. When a message comes with a new ID argument, the sender allocates an object ID for it. The interface used for this object is established through additional arguments. Excuse me. Or agreed upon in advance for the request/event. The object ID can be used in future messages, either as the first word of the header or as an object ID argument. The client allocates IDs in the range of 1 to big number, and the server allocates IDs in the range of more big number. The range of 1 to that. But there is an overlap now. IDs begin at the lower end of this bound and increment with new object allocation. The client allocates IDs in the range of 1. An object ID of 0 represents a null object, that is a non-existent object or the explicit lack of an object. To date, all known Wayland implementations work over Unix domain socket. This is used for one reason in particular: file descriptor messages. Unix sockets are the most practical transport capable of transferring file descriptors between processes, and this is necessary for large data transfers. So they just write to a file. Key maps, pixel buffers, and clipboard contents being the main use cases. In theory, a different transport is possible, but someone would have to figure out an alternative way of transferring bulk data. To find the Unix socket to connect to, most implementations just do what libwayland does. If Wayland socket is set, I think it is set. There was a way to check this. I did check this already. I think there are... Oh yeah, I think it's called $Wayland. I think Wayland display. And you can get the path. What is it called again? XTG runtime. So the combination of the two gets you the file descriptor. And you can check session type. Okay, I think that's what I tried before to make sure that it's actually using Wayland. Which the connection is already established. Assuming that the parent process configured the connection for us. If Wayland display is set, what is Wayland? So nothing. Oops. I think Wayland display is set. Okay. Wayland display is set. Concat with the XTG runtime directory to form the path to the Unix socket. Assume the path socket name is Wayland 0. Wait, it was Wayland 1. And concat with XTG runtime directory form the path of the Unix socket. Give up. Okay, luckily number 2 is present, so I think we can just use that. Okay, so if Wayland socket is set, interpret it as a file descriptor number on which the connection is already established, assuming that the parent process configured the connection for us. Interesting. Guess we could start by just connecting to the socket. I haven't done that in a long while. I think I'll do Wayland.zig. Standard is import connect socket. I think for now I'm not sure if it'll return anything. So what do we need? Well, display and the XTG runtime directory. How do you get Zig standard? Oh no. This is new. Oh no, this looks quite old. It's 5.2. Okay, I think this is the old one. Get env. Standard POSIX get env. Expects a key. Const. What's it called again? Wayland display is the POSIX get env. Wayland display display. This is optionals. Wayland display missing. Context tg runtime 6.get tnb directory. tg runtime standard debug print. I think temporarily just make it public. Wayland is equal to import wayland.zig. Dot connect socket. What's that again? Invalid format. S for type. Format specifies Zig. I thought it was pretty sure it was constituate. Yeah. What is the error? Valid format for that's weird. Oh, I think I need to return. Okay. And then I need to get the do we need an allocator? Maybe. Let me check socket. Domain, socket type, and protocol. I can never figure that out. How do you combine two strings? Self-constitute. Do need an allocator. No, I don't think you need an add list. So like a join. Something I always get stuck at. No, I think there's a better way to do it. Standard buffer init and yeah, I guess that seems easier. But the length is not comp time known. Okay, I think that seems the easiest. We need an allocator. Allocator. It's called socket directory. Domain socket type protocol. Sexto connect. Now I'm confused. Where do you pass the path? It's been a long while since I connected to a socket. Domain type protocol. I would assume when you connect. Let me get the path first. Allocator dot. You wait. Wayland display and plus dg time deadline. try, and I think we can do mem. Is it copy that way? Destination source. Socket path. Wayland display. This should be 0 to Wayland display.lan. Oh, but they also need a slash in between. Totally forgot about that. They concat strings with something. Oh, yeah, path.join. That makes it even easier. Sockets path standard fs path join allocator and okay, so this is gonna be, is it a pointer? Yes, it is. Slice of constituate Wayland, no, xdg runtime. Not a bad idea. Just test it out. Expected one. Oh yeah, needs an allocator. Vina dot allocator. Do I need to free allocator? Free. So I guess you only need the socket. Okay, I think so far so good. Now the question is connecting to, maybe there's an example here. No. POSIX dot socket. Domain, socket type, and protocol. What is the domain? Standard process POSIX dot socket. Socket add I'm not sure what the domain. I don't need that. Don't need that. It may be in the blog. Wayland basics. Opening a socket. What is going on here? Wayland display. Okay, socket is AF Unix. Socket type is sockstream. And then domain protocol is 0. These must be defined somewhere though. Protocol not supported. AF Unix. ELF auxiliary vector flags. What is that? Standard OS Linux. Is it the same thing? Is it AF dot Unix? Zig socket domain. Socket programming in Zig. Hang on, how do I know if this is... I mean, it looks... Socket bind listen accept. I mean, it looks like the right one. It's the... Where do I get the AF Unix? Can't be the same thing though. I think it must be here somewhere. Domain is U32. Because domain. Standard/C. What was it called again? Sockstream. Where are you defined? FreeBSD, FreeBSD. me. That's Windows. Zig For 6 socket. Oh, maybe here. Where can I find socket type? That was socket type. Standard 06. The Unix. Is that correct? I don't know. Standard POSIX sock dot stream. I'm not exactly sure about this. Sock FT. Okay, I mean, I do seem to get a file descriptor. It must be right. Okay, what happens next? Still haven't used the path though, which is quite... What do I do with the path? So, I will leave this on there. Concat with xtg runtime directory to form the path to the Unix socket. Okay, I think let's have a look at standard POSIX connect. So socket type, sockadder. SA family data. I think this is returned by the socket, if I'm not wrong. Initiate a connection on a socket. So FT is opened in non-blocking mode. The function will return when eCan or in progress is received. Have a look at the example. Address. What is? Slash. Okay, here. Family is Unix. What about the rest? Sockadder. Okay, so address to path. Six Sockadder. Const address standard 06 dot Sockadder. Family and data. What is family? Next domain socket address. Get some more coffee. Okay. What am I supposed to do with this? This is a fixed length array. Oh, okay, I see what you mean. Yeah, it seems UN. And I think I only need to specify the address. Family is already set, just need to set the path. So path equals, yeah, that's not gonna work. It's not the same type. But what I can do is copy. Is it mem copy or? Yep. Okay, now to connect socket. Okay, this is what is this return again? Socket T. Don't need that. Socket adder. And what was the last thing again? Socket length. It's just length of the address. Yep. Size of adder. Is that correct? What is this return? Connected and void. Shouldn't error if it worked. Can I copy constant pointer? On const sock address. This one here. Expected type. Okay, it expects a const. What am I doing wrong? Does it infer the type based on? Yeah, that's what I thought. .un. Yeah, there's something that doesn't look right. Should return sockadder. Say it again. No field named UN instructor OS Linux sockadder. I mean, which is technically not true, because Zig sock adder Unix. Even valid? No. No. I guess I can ask Cloud. How can I get a Unix socket adder? Zig. Yeah, but that's. Do I need to just cast it? And yep, this is a type of. I think something else is wrong. Yep, equals source and destination have non-equal lengths. Memcopy. Yeah, I think that is correct. Socket path dot len. um, Tell when socket is Unix and the given path doesn't exist. Standard debug.print. I just print bytes. Yeah. Print this as a I mean the path looks correct. User 1000 Wayland. Yep. Oh, hang on. Why is that an equal to? Why is file not found? Okay, it's returned. The path is right, but why? But I think I'm making a mistake somewhere else. Why are you going wrong? Why can't you find the file? Unix domain socket and family and path. Definitions of Unix IPC domain. Okay, the family is different based on which definition. I mean, that looks right. And the socket is AF Unix and the given path doesn't exist. But it does exist. Did I? I did. It's path.join. Mm-hmm. Alright, let me ask. This path does not exist. I've checked and it does. Can you see if there are any obvious mistakes? So I can't see anything obvious. The issue is that you're not null terminating the path in sock adder structure. Interesting. Really? Is that it? How did it know? Deadline is 0. Motherfucker. That was it. Well, I suppose it is an array, so it's not interesting. How are you supposed to know that? Well, I guess you're just supposed to know. Okay, that was just that was just a socket connection. I guess now we need to talk to. I guess what happens next? Well, let's check the book. Interfaces, requests, and events. The Wayland protocol works by issuing requests and events that act on objects. Each object has an interface which defines what requests and events are possible and the signature of each. Let's consider an example interface, WL surface. Right. Surface is a box of pixels that can be displayed on screen. It's one of the primitives buildings, like, hang on. I think I don't need to export this anymore. Let's call it Wayland connection. Turns void. Well, I guess it would return. Think standard POSIX socket T. Const socket is connect socket. Allocator. Mem.allocator. And then here, let's make this public. Let's call this connect. Still work. Expected error set type found I32. I thought that was the type now. Oh, my bad. Okay. That still works. I guess we can do the rest here. Connect Wayland socket. I think that's a good start. I'm gonna end it on a W. It's been a while since I've had a successful stream. I can continue here. Continue that tomorrow. And I think close that. I think I have this, have that. Okay. Yeah, I'll continue there tomorrow. And I think that was fun. I mean, it's a bit slow, but it's been a while since I've done any socket stuff. Maybe a couple of years. That wasn't too bad. Alright. Hope you have a good one. I shall see you back here tomorrow. And then the last few days I've been like quite hesitant to stream because I didn't know what I was doing. But I have like some general direction. So I feel a lot better. Okay. As always, thank you for hanging out. And I shall see you tomorrow.